Imagine our solar system, a place we know so well, a familiar cosmic neighborhood, a place of relative peace and predictable orbits, with planets and asteroids orbiting the sun in a timeless dance, a celestial ballet performed for billions of years. But what if something truly alien, something from beyond our solar system, crashed the party? What if an unexpected guest arrived from the depths of space? That's exactly what happened when astronomers using powerful telescopes discovered 3I/Atlas. This wasn't just another rock, another comet from our own backyard. Its path was a hyperbola, a curve that told a story. Proof it was just passing through, not bound to our sun, destined for somewhere else entirely. 3I/Atlas came from the darkness between the stars, from the vast unexplored regions of interstellar space, destined to return there, back to the cosmic ocean from which it came. The real chill wasn't fear, but awe, a sense of wonder at the sheer scale and mystery of the universe. Our solar system isn't an island, isolated and alone. It's a coastline, a boundary where our little corner of the cosmos meets the great unknown, and sometimes cosmic messages in the form of interstellar objects wash ashore. Atlas, a robotic survey in Hawaii constantly scanning the skies, spotted this interstellar visitor, this unexpected guest. But this was no ordinary object, no run-of-the-mill comet. It was moving too fast, blazing through our solar system at an incredible speed. Far beyond the sun's gravitational grip, it was on a trajectory that would carry it away forever. This was a one-way tourist, a fleeting visitor on a grand cosmic tour, a relic from another star, a piece of a distant solar system now passing through our own, briefly illuminated by our sun, catching a glimpse of its light before vanishing forever back into the darkness. The scientific community buzzed with excitement, a flurry of activity and anticipation. Here was a chance to study, to analyze, to learn from something truly unique. A piece of another solar system up close, a rare opportunity to examine an alien world. Was it rocky or icy? What was its composition? What secrets did it hold? What could it tell us about the formation of other planetary systems? Each new detail only deepened the mystery, adding layers of complexity to this cosmic puzzle. 3I/Atlas was a phantom, a fleeting presence in our solar system. A whisper from the great beyond, a faint echo of another world. Its arrival reminded us of the vastness and mystery of the cosmos, the sheer scale of the universe and our place within it. We had front-row seats, a privileged view of this cosmic event. To a show billions of years in the making, a performance that spanned unimaginable stretches of time. For a brief moment, a fleeting encounter, the universe sent us a visitor from unimaginable distances, a messenger from the depths of space. The ghost had arrived, a phantom visitor gracing our solar system with its presence, and we were watching, observing, and learning. Sometimes, the most profound discoveries are the ones that remind us, that bring us back to a fundamental understanding of our place in the universe, how small and how connected we really are, how we are all part of something much larger than ourselves. To study something as faint and fleeting as 3I/Atlas, a celestial object that appears briefly and then vanishes, you need the best tools available. So, with the clock ticking, astronomers turned to the Hubble Space Telescope, humanity's premier eye in the sky. Hubble's powerful gaze, with its unparalleled clarity and sensitivity, was our only real chance to capture this interstellar interloper, this visitor from another star system. Before it slipped away, fading back into the vast cosmic darkness from whence it came. The challenge? 3I/Atlas was incredibly dim, a faint whisper of light against the background of the universe, and it was moving fast. It was like photographing a moving coal in a pitch-black room, a task that demanded the utmost precision and care. The Hubble team, a dedicated group of scientists and engineers, tracked its path with unwavering precision, anticipating its every move. They meticulously planned each observation, maximizing the telescope's capabilities and collecting precious data, photon by photon. These weren't pretty pictures in the traditional sense, the kind that Grace magazine covers. Instead, they were raw numbers, bits of light painstakingly gathered by Hubble, data points that would ultimately reveal the object's secrets. The primary goal was to confirm if 3I/Atlas was indeed a comet, an icy body shedding gas and dust as it approached the sun. The team wanted to determine if it had a glowing coma of gas and dust, a telltale sign of cometary activity, or if it was just a dead rock, a fragment of something larger. Spotting a coma, even a faint one, would be the smoking gun, the definitive evidence. This would prove beyond a doubt that 3I/Atlas was an icy traveler, a relic from another star system, carrying with it clues to the formation of planets around distant suns. The world waited with bated breath as Hubble's data streamed in, traveling millions of miles across the vast expanse of space. This was more than just scientific curiosity. It was a fundamental question about our place in the cosmos. It was humanity reaching out to the unknown, attempting to understand the origins of our solar system and the potential for life beyond Earth. The images, once processed and analyzed, would be our first real clues to the true nature of 3I/Atlas, its composition, and its origins. And as the data arrived, piece by piece, the mystery surrounding this interstellar visitor only deepened, presenting new challenges and sparking further investigation. Speed in space is all about context. It's a relative measure, deeply intertwined with the observer's position and motion. What seems incredibly fast from one vantage point might appear quite different from another. Earth orbits the Sun at a respectable 67,000 miles per hour, a speed we rarely perceive in our daily lives. This constant motion is our baseline, the cosmic speed limit we're accustomed to. But then along came 3I/Atlas, an interstellar comet, clocked at a staggering 114,000 miles per hour. This celestial visitor shattered our perception of speed within our solar system. That's fast enough to cross the entire continental US, from New York to Los Angeles, in under 2 minutes. Imagine the sheer velocity required to traverse such a vast distance in such a short time. This incredible velocity meant it wasn't from around here. Nothing born within the confines of our solar system moves that fast. It was an outsider, a traveler from the depths of interstellar space. 3I/Atlas was a cosmic bullet, hurtling through our solar system at an unimaginable speed. It was breaking records previously set by other interstellar visitors, like the enigmatic Oumuamua, which captivated scientists with its unusual shape and trajectory. But the question remains, why so fast? What propelled this object to such incredible speeds? It's the result of the combined motion of our solar system as it journeys through the galaxy and the object's own inherent velocity. Think of it like two cars passing each other on a highway, one heading east and the other west. Their relative speed is the sum of their individual speeds. Our paths crossed for a fleeting moment in cosmic time, resulting in this incredible, almost unbelievable speed. The implication of such speed? Our window of opportunity to study it, to unlock its secrets, was vanishingly brief. It entered our solar system, swung closely by the Sun in a dramatic solar flyby, and was gone, disappearing back into the vastness of space, before we could fully grasp its nature and origin. This was a true cosmic chase, a race against time and distance, with telescopes around the world and in space racing to keep up with its blistering pace. 3I/Atlas's speed serves as a powerful reminder that the galaxy is a dynamic and ever-changing environment filled with countless objects embarked on wild, intersecting journeys. Our solar system is just one small stop, a cosmic way station, on a much larger, faster, and more complex galactic highway. Each encounter with an interstellar object is a rare and precious chance to glimpse the hidden stories and unlock the secrets carried by these cosmic messengers, these interstellar travelers from distant star systems. And just as quickly and unexpectedly as it arrived on our cosmic doorstep, 3I/Atlas was gone, leaving us to ponder the mysteries of the universe and the fleeting nature of cosmic encounters. At first, 3I/Atlas seemed huge, maybe several kilometers across. Scientists were thrilled, a massive relic from another star, ripe for study. But as Hubble gathered more data, the story changed. The object's brightness didn't match a solid, mountain-sized body. Instead, it was much smaller, less than half a kilometer wide. The reason? Its coma, a cloud of gas and dust, made it appear much larger than it was. We weren't seeing the object itself, but its glowing atmosphere. This revelation shifted our understanding. 3I/Atlas was an active, outgassing comet, not a giant rock. The downsizing wasn't a disappointment, it was a crucial clue to its true nature. Sometimes the universe hides its secrets in plain sight. In our solar system, small objects are usually rocks, asteroids, or snowballs, comets. Asteroids are dry, inert leftovers. Comets are icy, lighting up when they near the sun. Meteors are just the light show when these objects hit our atmosphere. Classifying 3I/Atlas was key. Was it a rock like Oumuamua or an icy comet? Hubble's observations revealed a clear coma, a halo of gas and dust. Only an icy body would do that. The verdict 3I/Atlas was an interstellar comet, the first unambiguous one ever found. It was a pristine snowball from another star, carrying frozen water and gases from its home system. This discovery let us sample the chemistry of another world, without ever leaving our own. For the first time, we had proof that comets from other stars really do visit us. The universe just got a little more familiar, and a lot more exciting. Tracing 3I/Atlas's origin is like following a ghost's footprints in a blizzard. We can map its path through our solar system, but beyond that, the trail vanishes. It was likely ejected from its home system by gravitational chaos, just like many comets in our own backyard. Its icy nature suggests it formed far from its parent star in a cold, distant region. By studying its chemical fingerprint, we compare it to our own comets, searching for common threads across the galaxy. Its age? Unknown. It could be as old as our solar system, or much younger. 3I/Atlas is a messenger without a return address, a testament to the galaxy's restless exchange of worlds. Its brief visit offered a rare glimpse into the cosmic diaspora. Whenever a fast-moving object appears, people wonder, is it a threat? With 3I/Atlas, the answer was always no. Its path was calculated with precision, never coming close to Earth. Its closest approach was over 100 million miles away, farther than the sun is from us. We watched from a safe distance, with no risk of collision. The real excitement was scientific, not survival. Systems like Atlas proved their worth, spotting and tracking this harmless visitor. 3I/Atlas was a cosmic fire drill, a perfect test for planetary defense and a spectacular opportunity for discovery. For centuries, we thought everything in the sky belonged to our solar system. That changed with Oumuamua in 2017, the first confirmed interstellar object. Then came 2I/Borisov, a comet from another star. Now 3I/Atlas joins this exclusive club. 3 discoveries in a few years suggest these visitors are common. We just couldn't see them before. With new survey telescopes, we're finally pulling back the cosmic curtains. Each interstellar guest teaches us something new: rocky, icy, fast, or slow. 3I/Atlas adds another crucial data point, helping us understand the population of interstellar objects. It's like discovering animals from a new continent. Suddenly, the galaxy feels more connected. These objects prove that material is exchanged between stars over cosmic timescales. Our solar system is part of a dynamic galactic ecosystem. The atoms in our planets may have come from distant stars, and now pieces of other worlds drift through our skies. We're not alone. The galaxy is full of travelers. The discovery of 3I/Atlas is just the beginning. With better telescopes like Atlas and Pan-STARRS, we're finding more interstellar objects every year. Soon, the Vera C. Rubin Observatory will scan the sky with unprecedented speed and sensitivity. We'll move from a handful of examples to a catalog of hundreds or thousands. With more data, we'll map where these objects come from and what they're made of. The ultimate dream? A rapid response mission to intercept an interstellar visitor, studying it up close, maybe even touching it. This is no longer science fiction, it's a real possibility. Each discovery brings us closer to understanding the